Hi, everybody. All right, we are back. It is time for part two of Schlansky's Guide to 65 Algebra 2 version. Mortgage problems. For mortgage problems, they're going to always give you the formula, and it's going to always be the same four variables. There's going to always be the same twist on each. Your P, your amount borrowed, is going to always be your total cost minus your down payment. Your N, your number of monthly payments, is going to always be 12 times the number of years. And the percent, just like anything, you always have to make into a decimal. So if his home is $172,600 and he has a $20,000 down payment, then P is going to be 172,600 minus 20,000. That is 152,600. N is 12 times the number of years, so it's a 15-year mortgage, so it's 12 times 15, which is 180. R is the monthly interest rate as a decimal, so because it's 0.305%, it's 0.00305. And then finally, M is the mortgage payment, which they're generally asking for. It's asking for the mortgage payment, so that's going to stay as M. So now I'm going to carefully substitute those values into the formula, which is right here. So M equals P 152,600 times R 0.00305 1 plus 0.00305 to the power of 180 over 1 plus 0.00305 to the power of 180 minus 1. And now I just typed it into the calculator. So I've got 152,600 times alpha x 0.00305, 1 plus 0.00305 to the power of 180 over 1 plus 0.00305 to the power of 180 minus 1 to the nearest dollar, 1,103. And that's it. Sometimes M will be on the right-hand side, in which case you would just type this whole thing into the calculator, and then you could just divide it away. In this case, I don't have to do that. That's it. Not a hard question. Let's move on. What is the exact value of tan of 3 pi over 4? Well, hey, calculator, can you tell me what tan of 3 pi over 4 is? Yes, Mr. Schlansky. I sure can. All right. This conversation is getting weird. Make sure you're in radian mode. In this course, you should always be in radian mode. Tangent of 3 pi over 4 is -1. There we go. Now, often you would have to type in each answer. So like for number 75, when I type in cosine of -5 pi over 6, cosine of -5 pi over 6, it's going to give me a decimal. So then I would just type in each decimal and see which one matches up. So choice 3, if I type in -3 over 2, those decimals match, and that would have to be my answer. That's the only trig thing on Guide to 65. The rest of the trig is really Guide to 85 stuff. All right, we've got the symbol for and, which is also the symbol for intersection. Intersection is both. Union is all together. Intersection is both. Union is all together. So, intersection is both. This is the symbol for intersection. U is the symbol for union. So what's in both? I got a 5. I've got a 6, I've got a 15. It should go in squiggly brackets. That's my intersection. Union is all together. I take everything I see in either set and I put it all together. If I see it twice, I just write it once. 6, 8, 9, 11, 15, 17, 18, 19. Intersection is both. Union is all together. And the complement is everything else. The complement is everything else. It's not what's in the subset. It's everything else. So if it wants the complement of B, since B is A, I, and O, it's not A, I, and O. It's everything else. It's SPH, choice 4. Or for or, it's a little word, but it's right here. For probability or, this is your formula for or. If it's asking you for or, we use this formula. If it's asking you for and, we use this formula. Unless it's asking for and it says independent, in which case we use this formula. So it's asking for or, so I write the or formula. P of A or B equals P of A plus P of B minus P of A and B. So P of A or B equals the probability of A is the probability of the first event, 127 over 466. P of B is the second event. Let's let that be the track team. That's 82 over 466. Minus P of A and B, track and band, is 74 over 466. From there, I just type it into the calculator. 127 over 466 plus 82 over 466 minus 74. Oops. Alpha x 74 over 466, and I get 135 over 466, and that's my answer. If I see and that's asking for, and it says they're independent, then I use my and independent formula. P of A and B equals P of A times P of B, yeah. So it's asking for P of A and B. P of A, the first event, is 48%. Always make your percents into decimals. Times P of B is 25%. That's 0.25. So P of A and B equals 0.48 times 0.25. 0.48 times 0.25 is 0.12. As a percent, because the answers are in percents, 12%. Now, two-way tables. So, for two-way tables, there are 4 different conditions. There is and. Here, let's do it this way. So this is basically the table of your 4 possibilities here. If you see and, it's over your total. 1 thing's over your total. 2 things. And you see given, the condition comes last. And if there are no keywords, then your condition comes first. So always total everything up. So this is 19, this is 81, 60, 40, 100. So if I see and, then my total is my denominator. Out of the 100 people, how many are male and in favor? Male and in favor would be 15. Probability female, well, that's one thing. So one thing, my denominator is my total, and my numerator is the total female, which in this case is 40. Find the probability that a male is in favor. Well, this is the most common. There's no keywords. There's two things. So the condition comes first. Male is the condition. Male is the group that I'm choosing from. So I'm going to circle the male row. Out of the 60 males, how many are in favor? 15. Find the probability that they are against, given that they are female. Well, when I see given, the condition comes last. So I'm given that they're female. So female is my condition. So I circled my condition. Out of the 40 females, how many of them are against? 36. I can only use the numbers that are inside the circle when I see a condition. So that's the 4 different possibilities. There's more practice after that, obviously. But if you see, I'll pull it up one more time. If you see 2 things and the word and, it's over your total. One thing is over your total. If you see given, the condition comes last at the end of the sentence. And if there is no keywords, but there's 2 things, then the condition comes first. All right, we've got independent. Independent is on the reference sheet. Independent is the same thing I circled before. It's P of A and B equals P of A times P of B. There's another independence formula. I think this one's way easier, so that's the one that I want to use. So I'm going to do P of A and B equals P of A times P of B. What's great about this formula is that there's no conditions, which means my denominator is my total for all of them. I'm going to total everything up. The denominator is a total for all of them. Gender and opinion. So I'm going to go A, female. I'm going to go B in favor. So A and B is 4. P of A is probability of female, which is 40. P of B is probability of in favor, which is 19. So now I'm going to type the left-hand side in, I'm going to type the right-hand side in, and I'm going to see if they match. So I'm going to type in 4 over 100, because it'll automatically reduce everything. So I got 1 over 25. And then 40 over 100 times 19 over 100. 40 over 100 times 19 over 100 is 19 over 250. Are they equal? No. So students sometimes get confused about what that means. This is the independence formula. This is the formula for independence. If it's true, they're independent. Since they're not true, it's not independent. If you chose different things, then you might get different numbers, but they won't equal. And if they tell you to use specific events, then use those specific events. Like in 90, it says Felipe wins and long practice time, so use A as Felipe wins and B as long practice time. Normally distributed. When you see normally distributed, that is your normal CDF. There's definitely some stuff you need to know about normal CDF, which is right here. What to do when you see less than. Less than, your upper is that value, and your lower is negative infinity, but I can't type that, so I write negative 9 and 9. More than 3, 3 would be my lower, and my upper would be positive 9 and 9. And if I'm between two values, then the lower is my lower and my upper is my upper. Once you put it into the calculator, if it asks for a probability, you're done. If it asks for a percent, times 100. If it asks for a quantity, times the total quantity. So, whenever you see normally distributed, normal CDF, so I've got my lower, I've got my upper, I got my mu, I got my sigma. It says less than 4.27, so that means that my upper is 4.27 and my lower is, well, as low as I can go, negative 9,999,999. However many numbers you can fit. If you like the number 7, do negative 777777777. If you like the number 6, well, then you got some darkness to you. All right, mu, my mean is 4.3. And sigma is my standard deviation, which is 0.05. So I go to my calculator, and I hit second vars, which is next to the clear button. Option 2, normal CDF, negative 9,999,99999. Upper is 4.27. Mu is 4.3, sigma is 0.05, enter, enter, enter. I get a decimal, 0.2745. There are 3 ways it could end from here. If it asks for a probability, you're done. A percent times 100, a quantity times the total quantity. It's asking me for a probability, I'm done. And I get my answer. Why do I have 0.2743 instead of 0.274? Oh, I just typed it wrong. 0.2743. In number 93, it said percentage. So once I got my decimal, I would do times 100. And in number 94, it's asking for a quantity, the how many. So I would take my decimal and multiply it by 1200. Those are the 3 different ways that it could end. Observational study, here we go. A survey, you're asking questions. An observational study, you're observing. You are not giving any of the groups anything. Whereas a controlled experiment, you are a controlled experiment. You are separating into a treatment group and a control group, and you're administering a treatment to the treatment group. Choice 1, for a class project, students in health class ask every 10 students entering the school if they eat breakfast. They're asking, that's a survey. 2, a social researcher wants to learn whether or not there's a link between attendance and grades. She gathers data. She's not asking questions. She's not giving anybody anything. That is an observational study. A researcher wants to learn whether or not there's a link between children's daily amount of physical activity and their overall energy level. During lunch at the local high school, she distributed a short questionnaire. A questionnaire she's asking. That's a survey. And choice 4, 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. 1 class gets a calculator, 1 doesn't. That is a controlled experiment. 1 group is getting something, a calculator, the other group isn't. That's a control group. That's a controlled experiment. This question is asking for an observational study. That's choice 2. Which brings us to bias. Bias is bad. If the sample is biased, it's not going to give accurate results. Bias is asking the soccer team if they like soccer. It's asking the chorus if they like to sing. You want it to be random. Every 10th person walking in the building in the morning. Yeah, you might get some soccer players. You might get some football players. You might get some chorus people. You're going to get a mix of everybody because the school is comprised of all those different groups. If it's not a situation where every member of the population has a chance of being chosen, as long as the 2 things aren't correlated, then it would be a good random sample. So let's go through the 4 choices. For 98, a survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. Yes, that's good. Everyone takes English. There's no correlation between being in an English class and studying, so that looks good to me. A survey of all ninth graders in a high school would be a good sample to determine the number of student parking spaces needed. If you're only asking ninth graders, that is not the entire population. That's biased. Also, ninth graders don't drive. If you're a ninth grader and you drive, yikes. A survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media websites. Well, yeah, adults aren't in a school lunch period. Lots of issues with that. The sample has to be part of the population, and not everyone is in a single lunch period. So various reasons that one's wrong. 4, a survey of all calculus students in a high school would be a good sample to determine the number of students throughout the school who don't like math. Are all students in calculus? No, if you're in calculus, you're really good at math, you probably like math. So asking calculus students if they like math is biased because they're more likely to like math than other students. That's bad. Choice 1 is good. Bias is bad. It's asking the soccer team if they like soccer. It's asking people who are good at math if they like math. 101, whenever I see this distribution, if it says anything about 95%, I find the confidence interval. The confidence interval is the mean plus and minus 2 times the standard deviation. There's my mean, there's my standard deviation. So I'm going to do 29.101 plus 2 times 0.934, 29.101 minus 2 times 0.934. I'm going to use my calculator. I got 29.101 plus 2 times 0.934. And I'm going to copy and paste it and do minus. Be real careful with rounding. They often tell you to round to something. It says to round to the nearest hundredth. So my confidence interval is always smaller to larger. To the nearest hundredth, 27.23, 30.97. 27.23 to 30.97. Now they're going to ask about a value, and you're going to either say, yes, it's expected because it's inside, or no, it's not expected because it's outside. The confidence interval is the range of expected values. It's used to determine if something is expected or unexpected, usual or unusual, plausible or not plausible. So they're asking about 30 minutes. Is 30 minutes plausible? Well, is 30 minutes in the range of expected values? Yes. So, yes, because 30, stay away from it in your explanations. 30 minutes is inside the confidence interval. 4 points for that. You kidding me? Am I done yet? Getting close. Margin of error. Real simple. You need to know that margin of error, or MO, is 2 times the standard deviation. It's a component of the confidence interval. It's basically how far from the mean I can be and still be an expected value. But all you need to know is that the MO, or margin of error, is 2 times the standard deviation. And again, make sure you round and read carefully. 2 times 0.042 to the nearest hundredth is 0.08. That's the answer to the question. Okay, one more question, right? That's right. What are the solutions to? Well, we can do Mr. X squared. We can do quadratic formula. We have to start with Mr. X squared. He wants to party. Before he can party, all of his friends have to come over. I know because of all the radicals and i's I see in my answer, it's not going to factor, so I would use quadratic formula. However, I don't have to use quadratic formula because I got polysimul. So I am going to go to apps. I am going to go to polysimul 2. It's in 7 for me. I'm going to go to option 1, polynomial root finder. I'm going to make sure that my order should default to 2, and A plus BI must be clicked. It is not going to be clicked. You must click the A plus BI. Next is the graph button. My value in front of x squared, also known as your a value, in this case is 4. Enter. I always like to keep the plus as plus, and if it's minus, I'll just put a negative as the next value. So negative 7 is in front of x, so negative 7 is my b value. My final constant, my c value is 8. I hit solve. I get 7/8 plus or minus. And then I get 1.111 ... and I've got an I at the end. So I know it's going to be 7/8 plus or minus, so choice 1 is out. I know it's going to have an I, so choice 3 is out. So I'm going to type in this, and I'm going to type in this, and see which one gives me the 1.111 ... I. Let's do choice 2. Radical 79 over 8. Radical 79 over 8 pi. Is that my 1.11 ... I? Yup, that's my answer. Make sure you get it equal to 0. It has to be equal to 0 first, and PolySimul will tell you that. When you go apps PolySimul 2, option 1, next, it's going to say equal 0. And then you just input your values, and if it gives you a decimal, then just type in the choices and see which one matches up. That's the end to the guide to 65. I have other things to do. I'm working on updating my Spotify, Apple Music, so that's what I gotta do now. I gotta do a couple of Algebra 1 songs. So I will leave you to that. Practice, know how to do your guide to 65, pass your exam, move on with your life. See ya.